pretty soon, maybe the degree to which we're on some flight ban by the TSA was linked to our credit score from Amazon, because TSA wanted to save money by outsourcing their trust network to a large company that has all of our information. That sort of silliness can happen if we don't consciously link automation.
Hello, everyone. Welcome to another episode of Dark Rhino Security Confidential. Today we have another awesome guest, but before I introduce him, I do want to remind all you guys to please show us some love and like and subscribe. It allows us to create such great content and to keep bringing these world-renowned guests to you. And today we do have a world-renowned guest. His name is Dr. Eric Daimler. Dr. Daimler hails from San Francisco currently, but he has a long history with my neck of the woods here in Pittsburgh. He was an assistant professor at Carnegie Mellon University. He was the assistant dean at the School of Computer Science. Currently, he is the CEO of Conexus, and we're going to talk about that. But he's got over 20 years of experience. He's served our presidents. He was in the Obama administration. He was the Presidential Innovation Fellow for AI and Robotics, helped drive a lot of policy, was part of the Columbus Smart Cities program. He's on the board at WelWaze Medical and Petuum. We're honored to have him. Thank you for joining us today, Eric. Appreciate you being here.
Oh, thank you for the kind introduction, and it's good to be here.
Well, let's start with, and, our audience always wants to know your beginnings. A little bit about you as a person. Was computer science always your thing, or how did you arrive in this universe? And are you a sci-fi fan? I want to know
that. Computer science has always been my thing. Yeah, I had my first computer at a precociously young age, built from a kit. And I chose Carnegie Mellon just because it was the best, and had come to Pittsburgh for my very first time in preparation for my first day of classes. I've been computer science bred, I guess you can say. I was originally attracted to it from this kind of sexy robotics side of it. That Carnegie Mellon is so well known for. And at that time, I had turned down MIT and Stanford to come to Carnegie Mellon.
Wow.
Because it had such momentum in those days, and I'm happy I did. It's been a lovely experience to have spent so many years in Pittsburgh.
So I gotta ask you, it's when you started at Carnegie Mellon, were you part of any of the research into the self-driving automobiles? That was pioneered here in some ways, right?
Right. Yeah. I often will talk to people when audiences with whom I speak about the history of self-driving cars as a relief to, or in contrast to, the hype that has surrounded this for so long that we'll have full self-driving next year, every year for the last 10 years or so. And that the history often informs a bigger, better view, which is that 1983 saw the first time that was we had this nav lab on the streets of Pittsburgh doing self-driving. I wasn't part of that research project. I was doing the distinction of balance in some robots earlier there. But I did find myself grateful to have Raj Reddy and Red Whitaker as mentors for me as I progressed through my education in computer science. And then later I went to Stanford and later developed an affiliation with MIT, but still, Carnegie Mellon is the special place to be.
There you go. And are you a Steelers fan?
You can't be in Pittsburgh without being a Steelers fan, right? I'm grateful that I had some very privileged places to see the Steelers play through a couple of the minority owners, and it's a lovely place. That is a party, I will tell you. For anybody that's not in Pittsburgh, maybe there, I haven't been to every football game in the country, but maybe there is others like the Steelers. But I'd say for anybody not in Pittsburgh, the they might want to fancy a trip to that stadium sometime, because it is like nothing I'd ever experienced.
So that's great that you've maintained that. And you were telling me they have Steelers bars in San Francisco, so I guess can't hold. Your loyalty is there. Thank you so much. I think everybody in this city is going to like hearing that. So, talking about AI, this term is used everywhere now. I don't think you can't even buy a vacuum cleaner without it having AI in it. But you know, give us a little bit of a quick primer. When we say AI, what does it really mean? Or it's much more than machine learning, right? There's a lot of different methods to it.
Yeah, this term is morphed. When I started in AI, and these things are all just a set of circumstances that I was, grateful to have grown up alongside when I was young. At that time, AI meant something somewhat different, in that it was AI as research. And once something became practical, it was really no longer AI. That term, and including artificial general intelligence, which is in the popular media right now, has really changed in its meaning. And then other affiliated terms, such as narrow AI. I think that the definition may not be quite as helpful in the pedantic, exacting way as something just more useful. What's a useful definition of AI? And I think of the useful definition of AI as something that can learn from a set of experiences over time. And these systems learn in a particular way. The car driving down the street we talked about with autonomous driving, they will learn as we have autonomous cars every few minutes driving down in front of my office. They will learn about the shadows that can then inform a further evolution of their operating system, but they're not going to suddenly learn Spanish, right? So we can constrain the type of learning that's really available. And when we think of these large language models, those aren't really learning in the way that we might anthropomorphize that to human experience. They are simulating learning by taking in a lot of information, but they're not actually learning. And that may be enough if you're simulating sentience, is often a term that people talk about in the concept of modern technologies. That may be enough to have some guardrails and frameworks with which to interact with these technologies. But these aren't learning systems necessarily, but they can simulate it. There's people that talk about it as learning, but we often will find ourselves well served to be careful around those particular terms. If we wanted to get a little more specific about this, there is a sleeve of AI where neural networks, the current expression that gives us large language models, is actually a subset of a machine learning, and that is itself a subset of a probabilistic or stochastic AI. There is an entirely different type of AI, which is a symbolic AI. These two types of AI will really represent the future because they come at problems completely differently. We often will talk in decision-making frameworks about bottoms up or tops down, and that's how these might be considered to approach problems. The popular, sexy, currently dominating domain is in probabilistic or stochastic AI, a subset of which is machine learning, subset of which is neural networks. It finds its expression in large language models. That is inductive. That's, if we remember our middle school logic.
Yes.
So in induction, and induction says something like this swan is white. These 100 swans are white. Oh, those 1,000 swans are white. Therefore, all swans are white. Right? That is induction. And you notice I could pick 1,000,000 swans that are white, or 1,000,000,000 swans that are white. But but and say, oh, all swans are white. And you can see the inevitable problem with going down that path. And there's no way, fundamentally, no way of correcting for that. That's just what induction means.
Right.
Whereas deduction is rules, call it symbols. You might say it's embeddings. That is like the Sherlock Holmes style, right?
Right.
All animals with wings are birds. This animal has wings, therefore it's a bird. Like just fact, fact, fact. Now, the weakness of that argument is you actually have to encode all the facts.
That's right. That was the old days of Lisp.
Man, it's funny you bring up Lisp.
I mean, I date myself completely. So
I remember a freshman programming assignment where I had to develop a compiler for a subset of Lisp in C. Wow.
You realize most of the people listening to the show probably have not worked in C, although most of the code that they write, a lot of it does get interpreted back to C. So that's the whole.
Lisp is an interesting language in dealing with logic.
Yes.
And logic had its day in the 80s, but the problem with that is we found very, very quickly that it didn't scale. You can't link knowledge in a way that would hold for kind of any amount of interesting domains. This was the intellectual conceit behind expert systems that found a marketing expression with IBM's Watson that was always a dismal failure. And we saw that coming for a decade, if not two, in advance of its IBM's managed decline. But that has changed. That whole underlying technology has changed, and it changed from a discovery in mathematics. There's this branch of mathematics called category theory that is just one of the branches of math that is shifting over the past couple of decades. We grew up taking these calculus courses, maybe even geometry and trigonometry.
Right.
That math is from the 19th century, and its use is probably in the 20th century, and in many cases should stay there. You could say the more math, the better, and all that. But if I was to choose the math of the future, probability, statistics, and category theory, that's a math of the future. The other types of math are maths. And maybe I'm being a little hyperbolic because you can call some things calculus and some you can call different types of things different types of algebra. But in a general sense, that's math of continuity. That's math for a physical world. It's math for civil engineering or mechanical engineering or aerospace engineering, which we still need. Right. But for a digital world, there's different types of math involved. This domain of category theory is an abstract mathematics, which sounds hard, it sounds difficult, it sounds fancy. It's actually a little easier than calculus, I find. So category theory is this sort of meta math.
That term, see, when you say it to the layperson, who it might strike a chord from their days in biology or zoology where, taxonomy is a big deal, and that's categorization. But I don't think that that's what you're implying here, are you?
I am talking about ontologies, and ontologist is actually one of the largest or fastest growing jobs at Amazon, because they obviously have an enormous taxonomy that needs to have this kind of encoded ontology across their system. I am talking about that. You can think of category theory a little bit like a multi-dimensional or n-dimensional, to be precise, graph theory. So graph theory is a part of where my research resided. Graph theory, people often may not recognize the term, but they'll recognize the visualizations that look kind of like spider webs. There'll be points, and then there'll be connections between those points that just explode into this, sometimes fancy looking creation of the web is often where people will see it. if you put that in a second dimension or a third dimension, kind of a richness of connections, that's where graph theory distinguishes itself from, or category theory distinguishes itself from graph theory. I'm not being, this is not entirely precise, but this is a way to be thinking about it. An example is that you and I are related right now by being on this podcast, and we also have a relationship of having a connection to Pittsburgh, or as two dimensions of relations. But if you and I were in a triathlon, that would be a different relationship you and I would have, right? It'd be a relationship as competitors. You want to capture all of those sort of relationships. Graph theory has a difficult time with that. Category theory is made for this. Where we have developed with category theory, or where Conexus AI started with category theory, is in transferring this knowledge, this meta knowledge, in databases. And specifically data models. So all of us have data models. Any of us have
and they can
ever
be
used
incredibly
Excel.
complicated, right? I mean, building a
Yeah,
data model in itself was an art and a science. People have made careers out of that. I mean, just look at anybody working at Oracle. In
that's right. The data modeling itself as a
right,
skill, I feel like, is diminishing, unfortunately. But all of our airplanes have data models
sure.
around them, and the one of the reasons that airplanes are so darn expensive is because we have to start over the next time we build an airplane. In many cases, we can't transfer what we had learned from the last database to a new database and design a new aircraft. That is limited by the math that is put to use. Category theory as a domain now solves that, so that we can transfer what we had learned from the F-35 and the F-22 into whatever the next generation of aircraft is. That's where the motivation came, where the Defense Department realized that us U.S. taxpayers spent way too much on those planes for a whole bunch of reasons, but one of which is we couldn't take everything we had learned about avionics from the F-16 and transfer it to the
Huh.
F-22 and F-35. So that's an example of these real world models, real world multidimensional models encoded in databases, transferring to a new domain in a way that we can bet our life on. That's a discovery in math that people don't talk about. It's not in the
So,
popular discourse.
if I was to oversimplify this for the audience, in a relational database model, you're going to have whatever data you're storing categorized into rows and columns that have various attributes against them. And this could be monstrous. I mean, this is a deluge of data. It's huge. Category theory will it allow you to take that data model that's already described all the relationships that it thinks exist between these data elements, and then take another data model that has the same thing that may be unrelated, and create join the two together and infer things based on the relationships that existed in both of them?
I mean, you're getting at exactly where I get excited in the applications of AI. Many of us are fascinated by the applications in English from these large language models for
Well,
AI.
thank Chat GPT for that. Yeah.
Yeah, and it's amazing how that is not only emerged but is progressing in its evolution. I use it multiple times a day. Uh, but where I am spending my time, where Conexus AI spends their time, where my colleagues, my collaborators spend their time, is in doing what we're talking about, what LLMs do, I guess you'd say, for data models. So we are composing. Uh, 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 we have compositionality among those data models. So we not only can look for inferences, but we will look for logical contradictions
Okay.
among any of these models. So an example is we looked at a design of a well, and if you design a well, you have to look at the surface and the subsurface and get opinions from geologists that are informed by satellite images, that also take in the contributions of a mechanical engineer and a civil engineer who actually have to build the thing based on the data from the geologist and the satellite images, and reconcile all of those increasingly sophisticated models into one. How that happens today is an iteration among smart people with, I'm not kidding you, email attachments of Excel
Of
documents.
course, Excel
Uh,
is the greatest BI tool in the world, even today.
yeah. But how much better would it be to have an AI just suck in all of those models, whether they're in Excel or Oracle or some other SQL database, most likely, and then reconcile the commonalities or contradictions among those models. Not only can it happen a couple orders of magnitude faster, but you also know that it's done with a level of integrity that you'd feel comfortable flying in, for example, if it was built on a plane. You're never flying a plane that was designed by a large language model, and you probably don't want, given the lives are at stake, an oil well to be drilled
No.
based on a large language model. But you can do it based on this neurosymbolic AI that helped reconcile the many different models that were brought to bear using category theory.
That is fascinating. Until this show, I had not heard of this. So uh, I'm going to be looking deep into this concept. It sounds if it can draw inferences, that is really really neat. I could see. I mean, wow, so many applications. I mean, you would the just in the simplistic way of accelerating the software development lifecycle, you could make it trivial, right? You
Yeah.
really could. If you have the category model, and I could say, all right, build me a data model that is focused on X, Y, and Z, right? Lay it out. This is the primary mission of the software that we're developing. Build us the backend database model. What
So the workflow in the future is a circle where what we will do is we will learn from a large language model, a stochastic AI, a probabilistic AI. We learn from those. And then the human interprets, the human expert contextualizes, and then encodes new facts into the symbolic AI. So we had a probabilistic AI, we had a symbolic AI with a human in the middle. And then we feed that back into the probabilistic AI, the stochastic AI. That's the virtuous circle in the future. This virtuous circle, notice, doesn't have middlemen. They don't have interpreters. They just the computers working together with the expert. This is providing some degree of optimism for me, thinking that yes, there will be jobs displaced, but we will actually have an explosion in the need for experts because experts in whatever domain are currently inhibited by the friction caused from middle layers that are interpreting other experts. If
Yeah,
you
absolutely.
have this system, experts can just interact directly with experts.
Yeah, absolutely. That's very true. I mean, you can think of any relationship there. There's always some frictional elements there. Anytime there's human interactions and wait times and things involved, it's going to take. If you're eliminating that, that's interesting. So let me ask you: is this technology currently at a point where you could even in let's pick like drug development, could it synthesize a brand new molecule, infer a brand new molecule for something, for an anti-inflammatory response? So it could go back and look, here's all the data that we have from all these millions of studies. Some were statistically done, some were drug based done, some are molecules that are sitting in the lab. um, can it take all that data, make it coherent, and say, you know what? These are some promising molecules that we should look at.
There's some things I know are going to happen, but the timeline is sketchy for me. That's always a dangerous place to play. On your domain, I'll tell you what happens today, where the technology resides today.
Okay.
You need to have a human expert. This isn't magic, right? So you'll need a clinician or somebody expert in the field as a researcher. I'm a computer scientist by training, an engineer by training, but I'm not I know nothing about biology. Right? What this does right now is it allows somebody expert in the field to ask questions to learn from some large model, And that large model will generate a query, and usually in SQL code, right? That's just how these things happen. You're querying a database. Where the AI comes in is the AI will make sure that we validate that query to make sure that the answer we get back can be trusted. Because right now, we have hallucinations, or confabulations is the accurate term. We have, stuff's made up,
Right.
right? We want to be able to trust the answer. And right now, what happens is we get back these answers, and then we have red teams, or otherwise just known as testers. And so we test and test and test and test and test and test and test. And in the case of drugs, we're willing to put a lot of resources into testing because the consequences can be catastrophic. How much better would it be to just apply the AI to the result? So you have a human expert that still has to do the query of the data.
Okay.
You have a human expert that needs to apply this AI as a validation. But when you get the result back, it can be trusted. So it's a safe AI. This makes LLMs safe, or confabulation free, hallucination free.
And
That's what it does.
That was the thing. There's a lot of, when you read the media today, there's a lot of sensationalization happening with AI, and you witness some of that when the Google engineer said, one of the guys said that this thing's become sentient, right? And it's going to take over. It becomes Skynet from what was that movie? Terminator. Yeah. Right. It can completely think on its own. And what you're describing in every step that you've described, the human being is a critical element.
The whole consciousness thing I think, is a little silly. Or if we're just going to be complimentary, I'll just say it's overblown. I am sanguine about that for a whole bunch of reasons we can get into. What we can talk about, though, is the degree to which that sentience is simulated, and the degree to which in many cases doesn't matter whether or not it's actually sentient or simulating sentience, because the power of the tools with which we're going to be interacting is on a different level than we have interacted with in the past, or even today. It's going to be transformative. But what I can say is we still need experts to interpret the data coming out of these models and to contextualize it. And what I can say is that wherever you are interpreting other people's work, be careful, because that's just ripe for automation. And I also can say that the way to prevent yourself from getting disrupted by AI is to be using AI. There's kind of two types of people that that are outside of that scope. One are artisans and people with niches, and that could either be by accident or by design, that we will continue to need or want. We still today in 2024 will buy handmade pottery.
Sure.
It's still enjoyable for all the reasons. I know, even though machine-made pottery's been around for a darn long time. So
Right.
there are niches and needs for artisans. But there's another type of person that I would want no one to be, which is the type of person that gets surprised when their job is automated. And that can happen for any of us, because the skill sets that we acquire, all of our skill sets, and we probably share this commonality, which is we learned how to program in different computer languages, such as Lisp,
Yeah.
that are just no longer relevant.
No,
That's
right.
a skill set that we acquired that has a half-life. And what I can say is the half-life on these skill sets, I think, will continue to shorten. We will acquire a skill set, and the value of that will diminish with an accelerated velocity relative to skills that we may have acquired a generation ago. So
I think
anyway, back to us participating in our own automation is where we want to be.
Absolutely. And what you're describing is an accelerated disruption. And it has been common throughout human history. So I don't think people should be surprised by it. I mean, anyone that studied human history will see, whether it was the Stone Age or the Middle Ages or the Industrial Revolution, there's always been that acceleration of disruption is happening with technology. And
What's changed is the abruptness of the
that's
change.
right.
Because early in my career, I was working for some banks where we were automating the trading of securities, and I just remember, the software didn't work, it didn't work, it didn't work, it didn't work, and it could continue not to work for years. But the day it worked, the day we could use a computer to simulate the trading of treasury bonds, I don't need to wait until Tuesday afternoon to fire the floor of people that were previously trading treasury bonds. That's what's different about today
That's
versus a
right.
generation or two ago, where people could kind of live out their careers and maybe not have their children go into those careers, but they could safely continue to exist. That doesn't happen today. And for the people living that experience, it's obviously quite disruptive.
Oh, absolutely. So, Conexus, how much? What are some of the focus areas that you're working on right now in terms of real
So
world applications? Yeah, who's getting disrupted? I guess. Let me ask you that.
Conexus AI is working with some of the largest organizations on critical infrastructure. So when lives are at stake, that's when you really need an AI, a neurosymbolic AI, to be put to use in migrating data, in upgrading applications, in integrating data models. Uh, our focus today is in this effort towards validating SQL queries. This can happen just millions of times a day across the globe, where people want to query their large language model, to query their organizational data. The SQL code is generated, and you need to validate that so that you can ultimately trust the answer. So this safe AI is a concept that you hear people talking about a lot. We can gab about it. People move their lips about it and talk about AI policy, but nobody I know of actually has technical solutions that can, with life and death accuracy, prove that your AI is safe, and that's what Conexus AI provides.
That's fantastic. Are you folks putting out any papers or documentation on category theory or educational content on this topic? For
Yeah. So
anyone that really wants to get into it, because we're not going to cover all of this in the next 8 minutes. I can guarantee you that, right? But I want to make sure that it sounds like such an interesting application that there's people who are going to want to know.
I am grateful for my two fantastic co-founders that are each better at mathematics than I am. I'm pretty good at math, and they're both better than me. One of whom is Dr. Ryan Wisniewski, but the other one is Dr. David Spivak. And Professor Spivak really opened up this field in 2011 with his discovery in the faculty of MIT, applying category theory to databases that made this whole thing turn out into something commercializable. He's written a couple of books on category theory that I can certainly recommend. But there are other category theorists. There's some in Pittsburgh, Carnegie Mellon. I don't know if there's any at Pitt, but category theory is a broad domain. We sponsor, Conexus does, a conference every year at Oxford on category theory. So it is a growing field of interest, and this has been around for a while. There's a adjacent discipline of type theory with which people may be familiar, and type theory is essential in quantum compilers. So quantum computing obviously has compilers, and quantum compilers would not be interpretable by humans if not for type theory, which is
Really?
kind of adjacent to category theory. So it's been around for a while. Also on the blockchain with
Yep.
smart contracts will use type theory. They will hire a lot of type theorists. So uh, quantum computers, smart contracts. This has been around for a while, but Professor David Spivak has some books. We've written some papers together. I can definitely recommend that whole body of research. There's other excellent books on category theory. Eugenia Chang often is brought up as the popular author in category theory.
Fantastic. What what do you see happening with the government's role in the governance of this fabulous technology, AI in general? And you were there. You were part of the president's administration,
Yeah,
right?
yeah, yeah, yeah. Well, I mean, when I was working in the White House, we were formulating the next vision of AI research for the next decade, ubiquitous collaborative robotics, and all that means. That's coming to fruition today, where companies need to think about how to safely operate robotic systems alongside humans. Right now you'll have many robots in dark rooms, essentially, where they don't have to be concerned about moving alongside uh, humans quite so much. But in airplane manufacturing or in some contexts around energy generation, you'll have people working more closely alongside of much bigger robots, and we need to be thinking about that. And that's where AI or symbolic AI needs to be put to use in this ubiquitous collaborative environment. I think for government, I am always skeptical, like many people about an overreach of some of this regulation, and there has been some ridiculous instances. I think by the City Council of New York, and
A
I
lot
even
of,
think
yeah,
now the City Council
yeah.
of San Francisco just doing this silly things to pretend that they are leaders in thinking about these areas when there's a lot of just obvious work that can be done with modern technology, and one of which is around data lineage and data provenance. We all know this. The consequences of having fake or misleading information being fed at us, and we're a little concerned sometimes about the algorithms that feed us, whether it's fake or just biased information to us. That can be addressed or help to be addressed through neurosymbolic AI, which is a fact-based AI. So you can require perhaps that data sources always be able to be found, and the lineage from which you may be receiving information can always be traced back to factual sources. That doesn't happen today, but it could be available. We also talk sometimes about circuit breakers. The state of California introduced some legislation where they talked about that, but in completely the wrong context. Uh, the way we need to have circuit breakers, which is another thing government could do, is have that just be available in certain circumstances to certain groups around the linking of automation, so that we just do this with intention is really the point.
Okay.
Because absent our intention, then we'll just have nerds in the basement like me that just want to reach our quarterly objectives. And certainly we'd like to think that we're thinking of the greater good, but we also just have our quarterly objectives. So absent other information, we're going to think it's pretty neat and potentially valuable to link this automated sequence to that automated sequence. And then pretty soon, maybe the degree to which we're on some flight ban by the TSA was linked to our credit score from Amazon, because TSA wanted to save money by outsourcing their trust network to a large company that has all of our information. That sort of silliness can happen if we don't consciously link automation, and that's often what I think we need to be talking about: circuit breakers of linking automation, and it's gone a little off the rails with the,
Well,
the
I think this is
California
where some
legislature.
common sense has to come in the picture too. There's,
Yeah, that's a truism. Yeah.
yeah. I guess that brings us. Boy, we didn't even get through any of this. Um, we have a couple minutes left. I want to give you the last 2 minutes. Is there anything you want to plug? Events, things, anything you want our audience to know about whatsoever?
Safe AI at Conexus AI. It's Conexus.com or SQL.ai, where you can sign up for an invitation to have your SQL code validated. Are two places that we can follow up. And then I'm on LinkedIn, kind of the usual outlets.
Well, Eric, it has been a pleasure. Thank you for being so generous with your time and giving us a lot of information That's just fascinating. We didn't even get to scratch the surface, but appreciate the primer, and thank you again. I'm sure our audience is going to be deeply appreciative of this episode.
It was a good time.